All right, so questions, comments?
Did mine look good?
I haven't looked at what you submitted, but I looked at your code before you submitted it, and it looked really good. So I'm expecting that'll be great. I've only graded one PA3. I glanced at one 8 o'clock this morning, and it was perfect. One for one. I will try to get PA3, PA2 graded before Monday. I can't promise, okay, because I got several things going on, and that's one of the things. But if it's not ready by Monday, I'll get it graded sometime as soon as possible. But hopefully by Monday. And then we'll talk about specifics of that, and we'll go through some sample code and so on and so forth. But any burning questions on PA2? If you did not submit, I think everybody here submitted. If you did not submit anything, please, 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 please always submit something before the deadline, right? Just if nothing else, just to let me know kind of where you are, and I can give you some feedback on that, and then we can talk from there to figure out what else needs to be done. But turn in something, even if you feel like it's just the very beginning of what you wanted to do. Put something in there. All right, well, let's take a look at PA3. So PA3, you're going to write a calculator program, and it's going to be a graphical thing. So it's going to be a GUI with buttons you can click on and a display that shows your numbers and the result, and so on and so forth.
Basic calculator, is that just multiplication, addition, subtraction?
There's some wiggle room in here. So so the fun part of this is I'm going to let you decide what grade you want to get on this assignment, because there are multiple pieces to it, and different pieces are worth different amounts of points. Okay, so the whole assignment is 5 points for turning it in correctly, so the right naming and the right type of zip file and all that. 10 points for documentation as usual, comment block with your name, comments on code, and so on. That's 85 points left for the behavior of the calculator. And those 85 points can come from a number of different criteria. So if you get something to display, right, I run this thing and it pops up something that looks like a calculator. It's got a display that says 0, it's got number buttons, it's got plus, minus, and so on. That gets you 15 points just by itself, even if it doesn't do anything. Okay? If in addition you can hit the number buttons and see your number build in the display, that's worth another 20 points. So now you're up to 35 out of 85. If you can actually do integer arithmetic, add, subtract, multiply, divide, so 2 plus sign 3 equals sign, and it displays a 5, right? That gets you another 30 points. So now you're at 65 out of 85. If you submit correctly and you put in comments, you've got 80 out of 100 already. Okay, so I don't want you to get stressed over the grade on this assignment. I want you to get stressed over, how do I do GUIs? How do I hook these things together? What should my code do, okay? I want you to explore and use this as kind of a framework around which you can start developing code, modifying code. You can say, you know, it'd be really cool if I could actually display a square root symbol on this button. I wonder how I do that. And so you dig into Unicodes and you find out about the set text method and so on. All right, so 30 points if you can do integer arithmetic. If you have a clear button which clears the current entry, so you type 2 plus and you start typing 3, 4, 5, 6, and then you hit the C button, it gets rid of that number that you were typing in, but it still remembers the 2 plus, right? So this is not the all clear, it's just the clear that you get. So that's worth 5 points if you put a clear button in. If it works with constants like 6 plus equals, 6 plus 3 equals, and it gives you 9, and if you hit equals again, it does another addition. If you hit equals again, it does another addition, and so on. That's worth another 5 points. If you go full bore and you can work with real numbers, numbers with decimal points in them, that gets you 15 more points. The most you can get is 85 points for this part, though. So you can't like ratchet it up to 1,000,000 points and then retire early. But if you work with real numbers, so you can say 1.2 times 2 equals, and it says 2.4, right? Then you got an extra 15. If you add scientific functions, at least 4 of them. So trig functions, square root, logarithm, exponents, factorials, whatever you like, that's worth 5 points. If you can try to divide by 0 and it does something other than catch on fire, right, like say, you know, error or something, that's worth 5 points. If you make it resizable, so that if you grab a corner of your calculator and drag it, the buttons grow, the display grows, everything still looks nicely placed, that's worth 5 points. So that's a chance to dig into some of the window managers and learn about grid layouts or things like that. A few deduction possibilities. So when you hit the 0 key, if that's the only thing that's being displayed as a 0, hitting 0 should not display a second 0. Right? Hitting 007 should not display 007, it should just display 7. So if you don't handle the 0 key correctly, that costs you 5 points.
Did you make a typo? Display 007 instead of 0?
That means incorrectly, sorry. So that's an example of not treating the 0 key correctly.
Okay, so it should display 7 if you do.
So it should display 7, yeah. I should make that less ambiguous. Okay, if you implement the decimal point because you're doing real numbers, hitting the decimal point more than once should not do anything. It should act like you only hit it once. Right? It definitely should not display multiple decimal points in your displayed number because it's not going to know how to add that. So 5 points if you don't handle that. These are really, especially the decimal points, really easy to handle. Hit a decimal point, set a flag. Right, hit a decimal point, make sure the flag's not set. Okay, the one big possible deduction is if your program crashes. Okay, so don't throw any exceptions. Where can you get into an exception? Well, for example, if you were to type 1.5 and try to convert that to a floating point number, you'll get a floating point exception. If you put it in a try-catch, I won't see the exception, that's fine. But if you don't do a try-catch, if you're putting in integers and you put in something bigger than 2 billion and try to convert it to an integer, you'll get an exception unless you catch it. Or if you have, you know, a null pointer exception or something. So I recommend after you've finished, or think you've finished your calculator, make an executable, and we'll see how to do that in Eclipse. Give it to a friend and say, break this for me. See if they can break it. Take their program, see if you can break it. Right? This is the Samsonite test. This is throw everything you can at it and see if it still runs without throwing an exception. Okay? Because you can think of what to test for, but probably anything you can think to test for, that's the stuff you coded for. And the stuff that you didn't think to code for, you're not going to think to test for. So it's nice to sort of get external quality testing.
Would it be okay to request that of other students in the classroom?
Sure, absolutely.
Okay.
And like I say, we'll talk about how to give somebody an executable so you don't have to actually give them your source code, right? So there's a way that Eclipse makes that easy.
Cool.
All right, so details. You're going to use Eclipse and Window Builder, and I want you to use JDK 8 or 9. Okay. Yes?
Already have it. Sorry.
Already have?
JDK 8.
8, perfect. 8's the one that seems to be most popular. It's one of the long lifespan ones.
Actually, the only one that even work in life.
Really?
Yeah.
Okay. I think the next long-term support one is 11 or 12, and I think that's going to break some of these things. All right, there's flexibility here on the design of the calculator. I have not given you detailed specs, okay? Your buttons should look like this, and these are the operations. So there's some wiggle room here, and it means we've got to be reasonable. Okay, so when I say it should look like a calculator, that's fairly subjective. Okay, but hopefully we have a common idea of what it means to look like a calculator. And if you're not sure, please ask early. Right? Show me what you're doing, and you know, I don't know if this counts as a constant. When I do this, this is what happens, right? But don't let the time that I'm grading it be the first time that I see your assumption. That might be different. So if you're not sure, just ask. Ask in class, ask in office, ask in Canvas, something, right? Okay, this part is really important though. There are tons of examples online of writing Java code to implement a calculator. It's a really, really kind of standard thing to try to do. And there's lots of tutorials on how to do it. There's lots of YouTube videos. There's lots of sample code. and you really got to stay away from those. Okay, they will get in your brain, and you will not be able to see any other way to do it other than the way that you've seen in a tutorial or in some sample code. And the goal here is really to go through the process of figuring out how to make a GUI and how to tie these components actions together and so on and so forth. And if you look at code for doing this, you lose the option of figuring it out yourself. Okay, so it's really important that you work on it on your own. If you really need to figure out, I can't figure out how to make something run when I click this button, right? So I'm trying to set up an event handler and I can't get it to work, I don't remember, and I don't know where the videos are, and my email's broken so I can't send an email, right? You can look up those things if you really have to, okay? But you're still better off going back to the notes, the videos, discussion on Canvas, Ask Me, office hours class, something like that. Because even in PA2, I'm seeing things where we talked about a way to do something and somebody did something totally different that required learning 3 new classes that we weren't even going to cover in this course because they're so complex. And a simple conversation of, I'm not sure how to do such and such, I could have said, oh, just do this, right? But if you don't know that, then you go off and you find some way to do it, and chances are the way that you find is way more complex. And in the tail of all that, you end up not learning this thing, which will pop up on a midterm, right? So my goal here is to help you succeed in this stuff, right? It's not a, you know, let's see if you can pass or fail kind of thing. So take advantage of me. All right. Your program should display something like a standard calculator, buttons for numbers, operators, and a display, and so on and so forth. It's got to be GUI. Okay, if you write a program that prints out on my screen, enter the first number, and I type it in on the keyboard and hit enter, that's not a GUI. And if you make a GUI that takes the place of my display and says, please enter the first number, and I type in the number and hit enter, that's not a GUI, even though it's appearing in a GUI, right? So it's, and I'll show you an example of what a acceptable calculator would be. And again, if you're in doubt about your design, ask. So we looked at grading. Here's a sample. Okay, so this is not terribly fancy. It's just blue buttons with black text. But this would count as something that looks like a calculator. Okay, so numbers for entering. I put a decimal point. I got a clear and an all clear, 4 operations and an equals, and a display on the top. And we'll talk about a suggested approach in class, how to break this down and what kind of steps to do, but I'm not going to put it in here because I don't want it to become like I have to do this and this and this. But we'll kick around some ideas. We're going to play with Eclipse in a little bit, and I'll show you exactly how to create the file that you're going to upload to Canvas. And you got to do it exactly the way that we're going to go through it in class. Because if you just make a zip file of your Java code and you submit that, it's not going to load into Eclipse properly. You're going to lose 5 points. Okay, so I'll show you exactly how to do this, and I'll show you how I'm going to take the zip file and use that to load into Eclipse so that you can try this on the file that you're uploading. You can see, okay, can I download it from Canvas, pull it back into Eclipse, and still run it? Okay, so that by the time that you're done submitting, there should be no doubt that you turned in the right thing. So one of the things you can do in Eclipse is you can create what's called a runnable jar file. So my main class was called Calc, C-A-L-C, calculator, not calculus. And I had Java create this jar file. So a jar is like a tar file, but it's made for Java. So it's a Java archive. And it's really just a zip file, but it's got some extra stuff in it. So calc.tar, calc.jar is, you know, gibberish. But you can say java-jar and then the name of the jar file, and it'll run your Java code. And if you've got GUIs, they'll pop up on your display. Right, this will not work if you do it on the server because the server doesn't have access to your graphical output and your mouse input. But if you do this on your own system, it should come up fine. And so 12 times 3 equals 36. All right, and if you go 2 times equals, there's 4, and if I hit equals, there's 8 and 16 and so on.
Times?
So that's this constant behavior that, at least I think calculators still do this. If you hit equal, it repeats the same thing. So I could say 2 times 2 equals.
Oh, that. But why did you say 2x?
Because it turns out if you actually just hit times twice, it multiplies by itself.
Why does it do that?
I don't know, but calculators do it. So here's the weird thing. I wrote this code, and I was just going to make a basic one-off, just to kind of like have something to show you. But all this other stuff started working like automatically. So I didn't code anything for the constants. I didn't code anything for scientific notation. And I
All of a sudden it's working.
absolutely did not code anything for division by 0. But if I do 1 divided by 0, it tells me infinity. And if I do 0 minus 1, there's minus 1 divided by 0. It tells me minus infinity. And if I do 0 divided by 0, it tells me not a number.
That's just cunning.
And the thing is, these are doubles, right? Because I wanted to have a decimal point, so I just made everything doubles instead of integers, and doubles do this for you. If you have a double that's 1, you divide by a double that's 0, you end up with a double that's infinity, right? It's like that double dot nan that we did in the rational class. And the constants thing I didn't code in, I just like tried it and it actually worked. And then if I thought about it, it made sense.
And it checks for 3 dot dot 0, right?
Yeah, so it should ignore multiple dots.
Right.
And it should ignore multiple zeros in the beginning, but then take them. So lots of wiggle room. Mine does not resize though, right? So if you don't put in a layout manager or something,
Resizable.
right, resizing just does this, so that's not considered resizable. I can change the size of the frame, but it's not really scaling up and stuff, right? So this is an absolute layout manager. That's the one we've been working with. If you use like a grid bag or a grid layout or a border layout or something, you can make it so these things are tied to the edges and they'll scale and move around in a good way. So you can experiment with that. And so if you give this jar file to a friend, they can try your program, tell you how well it works. All right, so questions about general behavior of PA3. Basic requirement makes sense. It's a good chance to have some fun, like I say, because it's cool to have a calculator program that you wrote, right? It's something you can put the code up on a repo somewhere and you can point to it in a CV or something you bring to an interview and say, yeah, so here's some GUI work I did when I was first learning Swing, right? Or whatever. And, needs no explanation. Everyone knows what it does. All right, so let's play with some Eclipse. So when you first fire up Eclipse, you may or may not see something like this. And
I get a welcome message.
You get a welcome message, right?
Tab.
Okay.
Tabs and options like create a project.
Okay, so there's a welcome message and there's probably a tab up here and it has a little X next to it, and if you click on that, that'll go away. And you may have to do the following: window, perspective, open perspective, other, and come down to Java. And when you do that, it will give you a window that looks like this. So there's different areas here. This area on the right I usually just close out. This is a task list. You can put things in your code that say this is something I plan to do in the future. you can say /** to do, and those tasks that you mark to do will show up over here. And it's a way that this tool will help you, instead of writing down on a piece of paper all the steps you still have to do, right? You can actually put it in the code, and you can see a list of them here, and you can click on them, and it'll take you to that section of code and so on. So we'll dig more into that another day, but you can make task lists and other things like that. I'm just going to close these out and concentrate on three main areas. This is the area where my code's going to appear, and I'm going to edit it. This is an area where, among other things, my output's going to appear. And this is Package Explorer. This is the list of all the different projects that I'm working on. So I have two projects in here right now. One is my calculator, the other is something called linked list, which is what we're going to play with. Again, try to get in the mindset where every time that you're doing something, it's its own project. Right? If you have multiple pieces to a project, that's one project. But as soon as you're going to try to write a main program and do something else, start a new project. And in general, you only want one project open at a time. So these two projects right here, they're both closed. If I double click on Calc, I get this little arrow next to it. That means this project is open. So if I click on that arrow, I can expand it, and I can come down to source, and I can come down on default package, and I can see my source file there, main.java. If I double click on linked list, that's the same thing. There's some source, default package, there's the Java files for my linked list project. Okay, so I would keep one project open at a time. So either go through and close all your other projects, or if you're working on linked list, right click and say close unrelated projects. That closes the calculator and anything else that's open. If I want to close this project, you can just right click and say close project. And if you want to open, you can right click and say open, or you can just double click. So keep expanding down to a source. We'll talk about packages later. These are the actual Java files. If you just double click, it'll open it up in the editing area. And it's tabbed, so you can click all of these. And now I've got three pieces of code that I can mess with. So this is a sample linked list class that I want to play with for the sake of exporting and for talking about debugging. So let's talk about exporting first, because this is how you're going to submit your code to Canvas. So I'm going to write out these steps. So this is for export. So only one project open. And then right click on the project and say export. So here's my linked list. I'm going to right port. I'm going to say export. And the first time you do this, it's going to look like this. So you're going to want to expand general. And then you're going to say archive file. And on this window, you should see the name of the class that you're dealing with, right? Linked list. And everything should be checked, right? So linked list is checked, class path project, those are both checked. Generally, don't change anything. Okay, it should come up in the right way. Don't mess with these options down here. The only thing you want to change is to archive file, and put in a path to wherever you want to save the file. So fill that in and then say finish. So let's call our archive 223b.zip. So I put that on my desktop like everything. So there's 223b.zip. If I open that up, it's got a directory called linked list. If I open that up, it's got source bin settings and so on. If I open up source, that's got my Java files down there. Okay, don't mess with the zip file. Don't try to add things to it. Don't take things out. It's got to be in a very, very particular format. Take this zip file, upload it to Canvas. All right, after you do that, I suggest trying to import that zip file. So download it from Canvas somewhere new. And then we're going to go through the following steps. So I'm going to close this project. So first thing you want to do is rename the current project. So it's got to be open though. So right click on it and say rename. Maybe it's got to be closed. Or open. Oh, refactor, rename. Okay, I'll put that down. Okay, so rename the project. Open the project. Right click, refactor, rename. So refactoring is a fancy word for renaming. If you have a variable in your code called, temp, and you keep calling this variable temp, but it really is, next node in the list to examine, and you keep coming across temp and forgetting what it is, and you'd really like to change the name of it to next node in list to examine, right? You could, with an editor, just say change every occurrence of temp to, this big long thing. And if you have the word temporary in a comment, that's going to change to big long thing rary, and so on. So refactoring is a more controlled way to make changes that are global but done in a reasonable way. So if you have a variable, for example, you can say refactor this. I want to change the name of this variable from this to that. And it'll only change it when it's actually referring to that variable. So for our project itself, we're going to right click, we're going to refactor. We're just going to do a straight rename. And we're just going to give it something else. So I'm going to call this linked list original. And the reason I'm renaming this is I'm going to try to import that zip file that I just made. And since that zip file is for something called linked list, if I have a linked list, it's going to say, you've already got a linked list, I can't import this. And I don't want to delete this in case my export didn't work. So I'm just renaming it, just to move it out of the way. And then I'm going to close this. And then I'm going to say file import. And on import, I'm not going to import an archive file. So I'm going to import general. And what you want is existing projects into workspace. So do next, and then you have to tell it what project you want to import. So this is going to, select archive file. And then you got to specify what file is that you want to import. So go ahead and browse to your zip file, which I conveniently put on my desktop and called 223B. And you should see the name of your project, and it should be check marked, and then you can just say finish. And that created a project called linked list. It's open. I can click through to that, to the source, and there's my code still intact. And if I run it, I didn't run the original, but if I run it, it does what the original did, which will show me on my linked list. Okay, so there's your steps if you take them from the video. And the most important thing is export, but you want to know how to import it to make sure the export worked. So export an archive file, import existing project into workspace. Those are the two big points to know.
What's that word under select archive file? Browse.
Browse, yeah.
You just click upload, or?
There's a browse button, and you click on the browse button, pick the path, and then you just say finish.
Selecting the okay.
And finish says go ahead and upload. All right, do this like early, right? Make yourself some arbitrary project, create 2 or 3 Java files, just make some class files. Don't have to do anything, they don't have to compile, they can, you know, have a shopping list inside or whatever. Hello world, or, you know, names for your kitten or something. And then go ahead and just export it, right? Make a zip file and rename it or delete it if you're feeling brave, and then try to import from the zip file and see if it brings you back to your 2 or 3 classes. And do that, you know, obviously before you've got your final project done and you're ready to turn it in. Because importing, exporting, that's a time where things can dramatically disappear.
Oh dear.
Yeah, exactly. All right, so let's talk a little about documentation. So this is a linked list demo program, right? So here's my main method. I create a my list and I just add a few nodes, and then I print it out by just concatenating to a string. And this is the standard integer linked list that we've been playing with for, you know, a number of weeks here and in 222. And I'm not worried about the code yet. I'm going to use this to work on some debugging later on, probably Monday. But let's say that it's time to turn this in and we say, I don't quite have enough comments in there, right? I can tell when people write comments at the last minute because they get filled with typos. And it's a good giveaway. So let's put some comments in here. This add method probably deserves some comments. Now I could say // you know, add method takes an integer and adds it to the list, right? But we can do something different because we're inside an IDE, and most IDEs will support this. So remember, you can do comments as either // or you can say /* a bunch of stuff //. Okay, I'm going to start a comment and I'm going to do my /*, but I'm actually going to put 2 stars. Now that's just going to be a comment that begins with a star inside there, right? It doesn't really mean anything to Java. But to Eclipse, it's going to see a comment starting with /*, right before a public method. And when I hit enter, it's going to do something unexpected. If I hit enter right here, it's going to write some more lines of comment. So it's got a star underneath, and it's sitting right there with my cursor, and the next line says @param num, and then there's a closing comment. So this is inviting me to write here a description of what the add method does. To write WRIT, not write. So I can say something like sample method for inserting an integer into the list in order.
So it basically creates the expandable comment block.
It does, exactly. And down here where it says @param, that means there is a parameter, an argument to this called num. And I can write a description of what num is right after here. So this is the integer to add, needs not be unique. I don't really say needs not in real life. Doesn't need to be unique. All right, and let's come down here to the toString method, and let's say /*, and I'm just going to put a description here. Return the linked list as a space separated string of integers. And let's go up here before the whole class, public class mylist, and let's put a description of that. So I'm going to say /*, and now when I hit enter, it also filled in the author. That's me, Nick.
Hey.
Right? And in Eclipse, you can tell it who you are, and you can also tell it what information you want in here. So I could have my company affiliation and all kinds of stuff like that. So I'm going to put a description of this here and say general linked list class for holding integers in increasing order. And if I hit enter, you know, it makes another star there, so it all kind of lines up nicely. Works perfectly except for bugs. All right, so I've got documentation here. Let's go ahead and document the node class. Class for holding a single node of the linked list. And we have a constructor. Construct a single node, and num, this is the data value to be held in the node. And I'll just say next is null to begin with. All right, so I've got comments in my code. My teacher's probably going to be fairly happy because each method has a description of it, and the class itself has a description in the top and has the name of me in it. But there's more than just comments in here. Because these are set in this particular way, we can run this through a tool called JavaDoc. And JavaDoc will look for comments that begin with a /*, and we'll look for certain keywords like @author, @param, and it will interpret those in certain ways, and it will generate a very nice looking document that describes all of the information in here. And you can run JavaDoc from the command line, but if you're in an IDE, there's usually a way to do that. So I can click on project, and I can say generate JavaDoc. And it's going to generate JavaDoc for my linked list, so that's fine. It should already know where the JavaDoc command is as long as you install the JDK. This says only generate doc for public methods and classes, which is probably a fine default. And then we need to put in a destination. So where should we produce this documentation? So I'll go on the desktop, and let's say 223B doc. And I'll say finish. And this is asking, do you want it to remember that destination every time that you generate the JavaDoc? I'll say go ahead and yes, record that. And so it gives you some messages here as it's working, and it says generating home NIC desktop 223B doc, and there's some files it created. So let's go see what it made. Let's go to our desktop, and there's 223B doc, and I got a whole bunch of files here.
Okay.
And if you've played with HTML, the main file you're interested in is index.html. If I put this on somewhere that has a web presence and you go to that directory, a web browser will request index.html, and that's the page that'll come up if you don't specify a particular page. And this is what it looks like. So there's documentation on my class mylist.
Okay. Wow. Wow.
And this looks exactly like the documentation we've been seeing every time we look up string or scanner or anything else. It's all a standardized format. So this is class MyList, and it's a public class. It's a MyList, which is an extension of an object. There's my description of it: general, linked list class, etc., etc. There's the author, Nick. Here's how you construct it, and I can click on the constructor and see that. And here's all the methods. There's an add method, there's a toString method. These are the methods it got from the object class, right? And if I click on the add method, public void add integer num, sample method for inserting, there's the parameters, it's just num, and so on and so forth. And if you have multiple classes, they'll show up over here on the left. And this is documentation that everybody who uses Java is used to seeing. And so if you're creating a class that somebody else is going to be using and they can get to a page like this, they know exactly how to navigate it, where to look for information, and so on and so forth. And so it makes your class more generally useful. So I'm not going to require Java documentation for PA3, but I will eventually for either PA4 or 5. So this is good to start messing with. And even if you don't do JavaDoc, right, you've got comments in there, which is important. Now it doesn't write comments on the lines of code, right? And certainly inside something like this, you need to say, well, what's going on in here, right? Why am I doing all of this stuff in an if block? Well, I got a comment, is this a new first node, right? Or else insert the node. But it helps you with comments in the beginning of methods, beginning of classes, and so on. So that's more stuff to explore, and we'll dig into it further later on. And there's more tags we can put in here than just author and so on. Okay, we got 4 minutes. Let me tell you where we're going on Monday. We're going to talk about debugging. So there's this Java perspective that we're in right now. If we say window perspective, open perspective, we can say debug. And it brings up a different view of our project, which for us is aimed towards running a debugger. And there's a debugger built into Eclipse, and it's kind of like GDB, but you don't have to type commands. It's all sort of point and click and stare. So if I go to my main method, I can double click on a line like 6. Well, let's double click on a line down here. And this sets a breakpoint. So when I run this in debug mode, it's going to run until it gets to LLadd1. And at that point, it's going to pause execution and ask me what to do. So I'm going to go under run and say debug. And it gets down to this statement and it's paused. Over here in the upper right corner, I can look at all of my objects. So for example, LL is a MyList. It's got an internal ID of 16. If I expand that, LL has a head, which is a node. And I can expand that head. It's got a data element of 2, and it's got a next element, which is a node, ID 22. And I can expand that node and see its data value is 5, and its next value is another node. And I can expand that. And its data value is 10, and its next value is null. And there's a picture of my linked list. Yeah, that's really useful, right? And so you still want to draw some pictures on a whiteboard or paper while you're using this, but this is a really, really quick way to go in and look at what's going on inside, inside your code while it's executing. And so you can step with function keys, so F5 steps into, F6 steps over. And in your code, you can also hover over things, and there's num's equal to 1. Here's here's head, it's a node, its data value is 2, its next node is ID 22, and so on. So you can use this, or you can use your code down here. You can single step, you can set breakpoints. That's really all you need to debug. Right, so again, as with GDB, this takes the place of putting in a ton of print statements. and it lets you sort of drill down to where the interesting stuff is happening, and then single step, see how your objects are changing, compare it to what you wanted them to do, and figure out where the disconnect is. So we'll play with this more on Monday. And we'll look at a few other aspects of Eclipse. We'll look at how to make those runnable files. We'll look a little more at JavaDoc. We'll talk some more about how to approach PA3, but I'm hoping you'll think about that over the weekend and get some initial ideas, and we can have some conversations about it. And then we're going to start looking at some other classes. All right, good to go? All right, have a good weekend. I will see you on Monday.